Hey, hello everyone. How are you doing? Welcome back to 15 days of React design patterns. And we are at day 11. In day 11, we are going to get started with performance patterns. Yes, it's plural patterns because we are going to talk about multiple patterns that can help you to optimize performance of your React.js app. What I have seen in my career coding with React.js extensively that most of the performance concerns come from only one thing, that is re-rendering. When your React apps re-render, when state changes, when props value changes, when context value changes, if the parent component re-renders, isn't it? So in all these cases, the re-rendering may happen. So if we can control re-rendering, I think we'll be able to address most of the performance issues. After understanding a part of re-rendering in React, we are going to talk about the techniques that we're going to learn in this session. Is called memoization, derived state, debounce, and throttling. We're also going to look into splitting components, virtualization, context optimization, React compiler. These all are different techniques through which you can control performance degradation of your application. And each of these pointers will bring design patterns that you can adhere to make sure that the performance of your application is taken care. As you can see, there are a lot of things to be done. I thought of splitting this session into two, part 1 and part 2. As part of part 1, we are going to cover from memoization to debounce and throttling, and rest of the pieces will be taken into the part 2, which will come immediately after this session. So before we start talking about any techniques, it makes a lot of sense to look into re-rendering and take some examples. Here on your screen, you are seeing an application. This application is a combination of a parent component and a child component. This particular text box, what you see over here, is part of the parent component. And on top of that, you are seeing something called rendered colon two times. That is a child component. Now, any changes that I make in the parent component in state changes, of course, the parent component will re-render. That's how React works. We have spoken about it already. When the state changes, props changes, context value changes, or the parent component changes, the re-rendering happen. So it's out of React's own philosophy. If I change the state of the parent component, the child component also re-renders. This is how it happens. If I put a letter over here, a character over here like A, I am seeing this 2 jump to 4. If I type one more called V, it becomes 6. If I keep typing, it keep increasing. So it means for every change of the state of the parent component, the child component is re-rendering. Now you might be asking question that, okay, fine, it is re-rendering, but why the value is going double? Why it is not single? It is because React runs something called a strict mode. That's why the re-rendering happens twice. Okay, this has happened only on dev mode if the strict mode is on. If the same code is running on the production mode, this is not going to happen. Now, this is the parent component, which is called render tracker demo. So what is this component doing? As I told, it has an input box. This is the input box. And it has a state called value. What is happening whenever there is a change happening in the input box, I'm typing certain character. I am just changing this value using the set value updater function that I get from the use state. We all know that. That means I'm changing the state of this particular component. Now, this component also has a child component, which is called render tracker. We'll go there in a moment. Now, whenever a state value changes of this parent component, React forces the child component to re-render. That is why we were seeing the re-rendering count. You don't see the re-rendering count anywhere in the parent component because the re-rendering count is kept in the child component. Let's go to the child component. Now over here, you are seeing this re-rendering count. It is happening. Renders.current, what I am showing. This is a simple React component act as a child component over here, which keeps tracks of how many time it gets rendered. Now, if you have seen the previous session, I clearly called out the difference between useState and useRef. useState, with every render, the value will be flushed out, cleared, reinitialized. But for useRef, in every render, the value will be retained. And also changes of the useRef value doesn't force for a re-render, whereas the changes of the state value force for a re-render, right? We have learned all these different nitty-gritties. Now here I have used the useRef because I wanted to preserve the value of rendering across multiple renders. And this is the same exact value what I'm increasing, I am displaying also. So it means that if my parent component re-renders due to this state change value over here, it is forcing the child component also to re-render, and I am able to see this over here. That's exactly we are seeing over here. So this is just to show you, just to set the ground that what re-rendering means. And sometimes re-rendering this child component because parent component is re-rendering might cause a lot of trouble. So all the techniques that we'll be talking about today in the part 1 are going to take care this kind of re-rendering which may not be required. How can we stop them in a optimal way? The first technique is memoization. What does it mean, memoization? It's basically a computer programming optimization technique, I would say, which to speed up your program by storing the result of a function's execution and then use the stored result, the cached result, if the input to the function doesn't change. So if we take a function, say fx, where x is the input and it produces a result, say y, and now we can cache this particular result, and anytime someone call this function, we will always return the same result as long as the input provided to the function remains same. This particular technique is called memoization technique. So it's a caching technique where you can cache the output value of a function and always return the same value as long as the input to the function remains same. If the input to the function changes, for example, from x, if it become p, of course, it may not going to return y again, right? It's probably going to return z. In that case, memoization technique won't be returning the old y value. Rather, it is going to cache the z value and going to return the z value again. This is how the memoization technique works. Now in React, there are three different ways we can do memoization technique. First, using a function called memo that's provided by React. Second, React provide a hook called useCallback. Using that, we can apply memoization technique on our React components. And the last one is called a hook called useMemo. Using that also, we can achieve the memoization on our React component and the React application. However, each of these techniques has got their own benefit and the disadvantages. We are going to talk about each of this technique, going to show some examples. However, in the modern React, there is something called React compiler, which we are going to cover in the part 2. And I've already created a video on React compiler extensively when it got released initially. But I'm going to talk about React compiler in the context of the latest version of React in the part 2, where we'll be talking about how some of this memoization technique like memo, use callback, use memo, you should be looking at if you are building a React application from the scratch today versus a React application that is already there as a legacy code with you. But that's part 2. Now in part 1, let's take a look into each of this technique one by one. First memo, then use callback, and then the use memo. Take a look into this application, almost similar to the one that we have seen before, that whenever this application got rendered first time, it logged something called rendered profile card. It means that I have a component called profile card and it rendered profile card. Now let me tell you, profile card is a child component over here, which is showing the profile information. Now in the parent component, like before, I have a text box over here, and look at what happens when I type a key over here. I'm typing A. The moment I type A, the profile card got the log for rendering profile card came here. However, this rendered profile card is there only in the child component. It is not there in the parent component. So it means like before, as we have seen, once the parent component is re-rendering, it is forcing the child component also to re-render. Now I keep typing character. If you see in my right side console, it's going to keep logging. It's again logging twice. I have given this explanation before. And in fact, you can see in the debugging tool, the one coming because of the strict mode is in much more muted color. Now let us take a look into the code. This is the parent component. Again, like before, I have an input box. I have a state called value and I am changing the value of it on every key type. And there is a child component called profile card. Whatsoever, this profile card is never ever related to this value. I am not passing this value as a props at all. I am passing a hard-coded name called tapas. That means this profile card is not changing because it has a dynamic prop value. It is changing because its parent's state value I am changing here using the on change you see over here. That's the reason by React's philosophy, the child component is re-rendering. Now, if I go inside this child component, it's a very simple component, takes the prop and it just says that render the profile card and showing that particular hard-coded prompt. Now, if I think that I have a child component and that child component I should not render at any cost until unless the input to the component changes, I can use the technique of memoization. And the first technique, as I told, is using the higher order function that React provides called memo. So the first thing that we'll be doing is to import the higher order function called memo from React. So I've imported memo from React, and then you have to encapsulate this entire React component function inside this memo function. You know what higher order function is? If you have followed my 40 days of JavaScript, I have clarified all these concepts very clearly. A function that takes another function as an argument or can return a function from itself is called a higher order function. So memo is a higher order function because now you can do something like this. You can use this memo and then you can pass this entire component function that we had to get a completely new memoized function. Now this memoized function is your memoized component. So instead of exporting the profile card, which you are doing before, let us just export the memoized card. Simple enough. So this is what you need to do. That much alone is enough. So you have imported the memo higher order function. As it is a higher order function, it can take another function as an argument. You have passed your component function, got a memoized function, and you are exporting from here. Coming to your parent component, there is no changes required. If you just want, you can probably this name as a memoized card because you are doing an export default. You can import with any name. It makes sense to do it as memoized card because you can then recognize it's something that you have memoized intentionally. Now the behavior will change. Here, first time when it got rendered profile card. Great. Now I'm going to press one character. That's going to change the state value of my parent component. But this is never ever going to change anything for my child component because child component is taking a hard-coded props, right? So first value, if I am pressing, nothing happens. My child component is not re-rendering because I am not getting re-rendered profile card again. I'll type more characters. I'm keep typing characters. You see here, my child component is not re-rendering. It is because the memoization is done over here and the child component is taking a hard-coded value over here. Like, so until unless this value gets changed, this props gets changed, the child component is never ever going to re-render even when the parents component state value is changing over here. So this is the first step. Now let us understand the next tool that we have is called useCallback for this memoization pattern. Now I didn't show you the application. Rather, let us start with the code because just now we have learned about this memo, isn't it? The memoization. So see, this code should be familiar to you. I have a component called child, and this child component is a very simple component which takes a props and then console.log says the child rendered and return a simple button. The button has a on click and click on it what function to call, that is what get passed as a prop. So this is a very simple React component. But the twist over here is that this particular React component is passed to the higher order function called memo so that we get a memoized version of it, and this is what we have exported from here. Cool, very simple memoized thing. Now let's go to the parent component. We have imported the child. Just like before, parent component has its own state called count. It got its own button called increment. The moment I click on this button, the value of the count goes up by 1 using the set count updater function. So on click, I am calling this set count plus 1. It means this count value will be increased by 1. It means I'm changing the state of my parent component. I have also used the child component over here, and as I have explained, the child component takes a on click props, which is over here. I pass the function that should be executed when somebody click on a button which is inside the child component. Now, what do you think is going to happen if the parents component state count gets changed? So far, we have learned that using memoization, if the child component can be passed through the memo higher order function until unless the input gets changed, my child component is never going to re-rendered even if the parents component state gets changed, parent components re-rendered because of any reason. So in this case, Anto is satisfying two cases. One, the child component is already memoized and the props of the child component, the props value of the child component is quite static. It is never going to change. So it means that if the parent component state changes because of this button click, the child component should never get re-rendered. I should not see this console.log child re-rendered when I am clicking on this increment button. This is what my expectation. Now let's go and look into the application. So first time, of course, app rendered, child rendered. That's great because first time it has to render. Now I'm going to click on this increment. Look at here what happens. I click on increment. Oh my God. It again printed app render, child render. I click over here, app render, child render. Oh my God. So that means when parents component state is getting changed, child component is also getting re-rendered even when I have used the memoization technique. Why is it so? So here basic JavaScript come into picture, guys. No React, nothing. React memo is fantastic. It re-render your component only when the prop changes. However, when comes inline functions like this, though it looks like it's a static function I am passing to on click. Now, the beautiful part of function is just like an object in JavaScript, it's of reference type. So on every render, a new reference of this function will be created. So if a new reference of this function gets created on every render, it means the on-click value on every render of this component is new, isn't it? First time when my parent component got rendered, this particular function's reference value was, let's say, x. Now when I click on this button to change the count value, that is the state of my parent component will get re-rendered. The moment the parent component get re-rendered, this particular line, this particular value will get a completely new function which is having a new reference in the memory, though it may look exactly same with the previous version of it. As it's a new reference, completely new function, it means the prop value had got changed. So of course, the child is going to get re-rendered even when the memoization has been applied. So this is what you need to really observe closely. Inline arrow functions break memoization because they create new identity every render. This is the thumb rule. This is the mental model that you need to keep it. Now to fix this, React gives us something called useCallback. That's a inbuilt hook that React gives us, which helps by stabilizing the function references. So it means that when I use callback hook is never ever going to look into only the shape of this particular function. Rather, it is going to look into the reference of it. So far whatever happened is like inline function, every render, new reference created, new reference got created means props value changed, my memo breaks and my child component got re-rendered. But with use callback, it will ensure that react.memo will see always the same object. Can you change the code? Yes. Now to change the code, it's pretty simple. Let us take this one, the on-click one, into a function called handle click. And over here, let us import use callback and define const handle click equals to use callback, which takes a callback function inside which you have to write what you want to do. Let's say I write console.log of say clicked, and then you have to pass something called a dependency array. So this dependency array is similar to what we have seen in use effect earlier, right? If you don't pass anything, it is just once. But if you can pass any dependencies, whenever the dependency changes, only then you explicitly tell that even if the memoization applied on the child, I want to re-render the child. But until unless my dependencies are not changing, their value is not changing, use callback would ensure that even if you have a memoization over here, will ensure that your child component doesn't get re-rendered, right? So that's the difference. So with this, can we run this app? First time, app rendered, parent rendered, child rendered. Now let me click on increment. Only app rendered. I don't see child rendered anymore. Only app rendered. Only parent rendered. Now if I click on a button that is there in the child, I'll only see the child rendered. So click, child clicked, only child rendered. If I click on the parent one, only parent rendered. You see this? Now my memoization technique is working really well. So what are the things happened over here? When I click on increment, my parent component re-renders. But the handle click function over here doesn't get recreated because handle click is now very much memoized using use callback. Child receives the same function, this handle click function, always on every re-rendering of the parent. As the handle click is not been recreated, it always pass the same reference. That means the value of on click remain intact just like before, and then child doesn't get re-rendered. Now imagine if there is a dependency value that I am passing to use callback, and if the dependency value changes, only then this handle click will have a new reference. And that reference value goes over here. That means the props value of child changes. Now child gets re-rendered. This is exactly, guys, use callback does. Now, many people just use the syntax, but they may not understand the depth of it, like how it works. I tried my best to give that to you. I hope it makes sense to you. And I want to know, like, how is this 15 days of React design pattern going, guys? If you are taking this course, I'm putting a lot of effort. Believe me, lot of effort. I would love if you can share a few words about it in the public. If you can tell people like something like this exists, so that more developer who really wants to learn and want to grow senior, not in terms of years and the age, but by experience of handling React project, for them this will be immensely useful. And making something out for free, I feel really proud to giving back to the dev community. And if dev community also can help me to spread the word about it, that will be really great thing. Thank you, guys. So let's move on to the next one, which is use memo. All right, coming back to the use memo. So here is a simple demo. Okay, don't look into this name too much. I have used the same name. You can use many random names, for your demo. So what is happening basically? Again, the parent child relationship in the components and all. So the parent component is having this number and the increment, just like before, a count. So if I click on this number gets incremented. That's it. And the child component has a sorted array and listed each of the name from the sorted array. Right now, I have listed about 1,000. You can make it like 10,000, 100,000, 1,000,000, whatever it is. Consider it's a big array. Inside that array, you are performing sorting mechanism or sorting algorithm. Now, what happened? Due to our parent child relationship and how React works, we know that if the state value, which is the 0 of the parent component changes, it is going to force this child component also gets re-rendered. Over here, if you see on the first render, user component re-render, it is coming from this particular sorting thing. This is the user component. Now, if I click on the increment once more, I can see the user component re-rendered happen once more. If I click again, if I click again, if I click again, every time I click, it is going to happen. Coming back to the code, this is my parent component where I have that button, increment button. And as you have guessed, there is a count state. Clicking on that increment button, I am setting the count by incrementing its value by 1. That's it. That's all I'm doing. Now I also have this child component where I'm listing all that usernames, and the usernames are coming from a method called say get user that I have written in my utils. It is there. It can return 10,000, 100,000 usernames. Okay, and this users is what I'm passing as a prop to my users component, which is a child component. If I go to the users component, it takes this prop, it put this console.log. That's what we have seen, user component re-rendered whenever the count gets incremented. But here I am doing an operation, I am sorting it, and then the sorted user I am putting over here. Simple component, but there are a lot of problem in the line number 4. The first problem is I am sorting this array, which is a huge list of user object, for example. Now if it has a 100,000 user object, this is going to make this sort every time this component gets re-rendered. So that's the first problem. Second problem, I am actually mutating the original list of user, right? Which may create certain issue because ideally I should be creating a copy of it and then only do the sorting. As I am sorting the large data and this is just getting re-rendered on every button click or say every key down, it takes a lot of time to process this sorting, right? So that slow down my UI. And we all know if the parent re-renders, child re-renders, so sorting happens every time. Now, this is not a great use of my energy and time to have this kind of sort going. Though we have taken the example with sorting, but there are other such functions like filtering, running any kind of expensive computation, formatting heavy data, doing object or array transformation that produce new functions, new objects, new references, all are going to create similar kind of problem. And that's exactly where useMemo comes in. UseMemo helps you to cache the computed value until its dependencies change. Use callback, we have learned that what it caches the references until the dependency changes. We have seen it with function. UseMemo cache the value until its dependency changes. Imagine useMemo as something which memoize the return value of the function and it cache it. It always return you the same value if the input remains same. If the input changes, it is going to return you the change value and again cache that value, so that from next time it can again return you the cached value if the input doesn't change. Now the same code we can change with useMemo pretty well and pretty easily. For that purpose, first thing first, import useMemo from React. Let me comment out this sorted thing and let me write the logic for sorted using useMemo. So I'll have useMemo. This again take a callback function, and just like use callback, you can pass a bunch of dependencies over here. Instead of mutating this list directly how I was doing before, let me first create a copy of that list using the spread operator. And on top of that, I can do this sorting logic. So I'll be just copy pasting this one, and this is going to return me new sorted array that's I'm going to return. And as and when the list changes, I am ready to do this computation. If the list doesn't change, I am not ready to do this computation. So you understood? useMemo is a hook that takes a function and a dependency array. That dependency array decides when the input changes, then only whatever you have written inside this callback function has to execute. Otherwise, it won't. So what execution we are doing? If this list changes, then only it makes sense to sort it again. And then the return value will be over here, which we are already using to map it out, right? Isn't it? All right, now let's go to the UI and see what's happening. So first time, on the first render, it says the user component rendered. Great. Parent rendered and child also rendered. And it's sorting the expensive list. So first time the use memo got called because list, the value of list supplied for the first time to the child component, the user component. Now, if I increment, what happened? If I am incrementing, I am saying that user component rendered, this log I got. However, this sorting expensive list log has not come. That means if I keep incrementing, of course, my parent component state value changing. So why my child component is also getting re-rendered, because child component I have not memoized. Entire component I have not used in this case inside the memo higher order function. So it will definitely re-render. But even if it is re-rendering, the heavy computational logic, the sorting logic, that is not getting executed. See, I'm incrementing. Only first time it came, sorting expensive list. But rest of the time, it is not coming. So if I go to the code again, this will be coming every time because this child component is getting re-rendering. That's fine. I'm completely fine with that. But this computation is not happening again because this list is quite static. That's what I have got from my utility function. If this list changes, only then it will be recalculated again, and only when you will see this console.log once again. So for any kind of such expensive operation, it's always good to use useMemo. Now again, the catch over here is please don't use useMemo for any smaller computations. It is not going to save you much. See, even to look into, like if some value is cached and then only return the cache value or return the new value, it requires certain computation within. React is computing something at the background, right? Now for a smaller calculation, like for 5,000, 10,000 values, why would you do that? If the value really grows, where your application performance, the search, the button click, adding to the cart, something is getting very much sluggish. Only in those cases, think about using it. Don't use it just because it is there. Sometime eagerly optimize the performance of your application may introduce more performance bottlenecks. So you have to be really careful where you should be using, where you should not be using. So I hope the memoization technique is quite clear to you. Now let us talk about the second technique. Can you sense what is wrong here in this code? So this is a simple cart component. What I'm doing basically, I'm taking the number of items that are there in the cart and then computing the total number of price that somebody has to pay, the total amount somebody has to pay to purchase the item there in the cart. And then I'm just rendering that total value over here. Very simple. I kept this use effect over here to calculate the total sum, the total amount that somebody has to pay. And that's how, after computing the amount, I'm just changing my state variable. And this is what is going to reflect over here. Is there a problem that you see in this code? If I run this code, it will beautifully run. If I just pass an array of items with their price, it is definitely going to run and give me the total rendered on the component. Then what is the problem? The problem here is with something called derived state. That's another thing that causes a lot of performance problem if we are not careful. What is a derived state? Derived state is any value that can be computed from existing state or props. Okay, again I'll repeat. A derived state is any value that can be computed from existing state or props. For example, you have a list, you can derive the filtered list from there. You have the cart items, you can derive the total amount for the card. You have a text, you can derive the length of the text. You have a boolean, you can derive the enable disable states from that. Derived state should not be stored in another React state. This is a problem I have seen tons of time whenever I reviewed code in my life. Derived state, again, the rule, derived state should not be stored in React state. Why? Because storing it cause unnecessary re-renders, which is the cause of many problems in terms of performance of your React application. Secondly, if you are storing derived state as another React state, you have to synchronize between the original state versus the derived state. What if your original state becomes stale? Your derived state still out of sync. You have to do a lot of complex logic sometime to manage this synchronization, right? And always you are doubling down on the re-rendering whenever certain updates happening. Why do you want to do that? So that's exactly the problem over here. Now, if the same card component I have to rewrite as a better card, it will be much more simpler. See how it is. I'm getting the items from items using the JavaScript reduce method, which is the exactly same logic that I have used over here. I am now computing the total and then rendering the total. That's it. Whenever the props change, this value will change. Why I have to do another use effect? I have to manage another state, another derived value for this as a state and use it. Now there is no basically unnecessary things happening over here, right? I have reduced the load a lot. I have written very less number of code over here. So this is an anti-pattern, storing derived state in use state. What we have seen over here, please stay away from this. Now here is one more example. Tell me whether it's a good example or bad example. I have the users component. I am taking a list of users and then I am filtering this. Maybe this list contains 100,000 users. So of course I have used useMemo. By now you know why we used useMemo. It's a expensive time taking computation. So as long as the user list stays same, I don't want to filter them again and again. So it filter out only the active users using this user.active. This active users get returned and I'm using active users over here as a map. Is it a good practice? Bad practice. Now, first thing you need to answer. Am I using any derived state? No, because I have not declared anything with use state. And this particular guy, whatever I'm using in my JSX, is not a state. Because to make it as a state, either I have to use state, use reduce, or things like that. I'm not using. It's a simple variable that returns a heavily computed value. I'm using useMemo because I care for it, because my list may have 100,000, 1 million users. So active users now has computed, heavily computed user value, and then filtered user value, active user value, and then I'm just rendering on my JSX. That's it, simple. So no derived state is a good way of doing things. However, this one, of course, this is wrong because I get an age, then again, like before, based on the age value, I am checking whether the age is greater than equals to 18 or not. In that case, the person is adult. So I have a Boolean value is adult, and based on that, I'm saying adult or minor. I don't need this computation inside use effect. I don't need this derived state. I get the age. I just have a variable called const is adult equals to age greater than equals to 18, and then use is adult directly over here in this condition. That's it. Correct? So no derived state, no drama, extra drama in your code. This is another one I have seen in terms of form. This is taking name and email. I have to validate it. Why would I create again a state called is valid? And again, why I use is effect unnecessarily? Whenever the name and email changes, I am marking as whether the is valid is true or false, and based on that, I'm taking a call. No, don't do that. Rather, create a variable called const is valid equals to this particular logic. So whenever name and email prop changes, that will be called, and then is valid you use as it is. That's it. No derived state at all. So these are some of the practices I hope that you keep in mind. And I hope you understand why derived state is bad and how you can get rid of it as much as possible. Now let's go to the next technique. The next performance technique or the pattern that we're going to talk about is called debouncing. Now again, if you are someone who is following me and following 40 days of JavaScript, you know that I had a session on performance optimization of your JavaScript app, and there I have explained debouncing and throttling and concept like that visually, right? Now I'm going to explain it over here also, but let's see the problem first. Let's imagine this is a portal where I can search user, and this makes an asynchronous call on an API, fetch the data over the network and display the search result, the match result at the bottom. I have not implemented that entire stuff, but I've implemented it so far so that I can show you the demo. So here, as and when I type something like tapas, if I type on my every keystroke, you can see a console.log appearing over here, which is given at the place where I'm making the API call. So if I type tapas, if you see that I've made an API call with tapas. It means that for every keystroke, I have made an API call. Now, these API calls are not cheaper. They are costly. They are expensive. Why they are expensive? Because you have to make them over the network. And then some of the API calls may have rate limit. You probably have to pay for those API calls once you pass the threshold. So you got to be very sure that you are not going to call this API so rapidly. Rather, you need to have certain mechanism where you can actually control this. This is where debouncing come into picture. So what debouncing is? Debouncing is a technique through which you can delay the execution of a function by certain time. Okay. Now, one thing you have to remember over here, whenever I'm typing something on my input text box, I am actually triggering an event. That is what? On change event. Now, through debouncing, you are not controlling that event. You cannot control that event. The event will happen. The on change event will trigger. But due to the on change event triggering, you were calling certain function of the API. You can control that. Okay. Some folks, they get confused with, oh, debouncing means I don't trigger the event at all. No, event will be triggered, but due to that event trigger, there is to be a function call. That function call will not happen for a specified time that you decide what is the specified time. All right. So this is what the debouncing as a whole. Now, to implement this debouncing in React, we will be creating a hook, and I'm going to explain the code in detail. But before that, so far, look into this search component, the search box component. As usual, it has a state called query. Query means whatever you're typing inside the search box, whatever the value that you type inside the search box, that value set inside this query variable. And you update the value every time somebody type on this input type text box using something called onChange, right? This is change event. And using the set query updater function, whatever the value there inside the input box, you set as a query and your state value gets updated. You have a use effect. We all know what it is. It has a dependency called the same query. So it means that whenever the query gets updated, let's make an API call. And here we have simulated an API call like fetch call. I don't have the call in real, just assuming there is an API. So what is happening every time I'm I'm changing something, this query gets changed and this use effect gets executed. I'm seeing this API call with this query every keystroke. Now, my intention would be I limit that. I don't make this call, I don't make this one executed for a specified time delay. For that purpose, I have now a hook call use debounce. This takes two parameters, very important. One is a value, which basically influence the change of the query. Basically, that's the value. And there is a delay that I specify. Here, I have put a default delay of 500 milliseconds. You can put the delay, whatever the delay that you want. Now, if a delay is passed from outside, this will be overridden. This 500 millisecond will be overridden. If it is not passed from outside, it will take the 500 millisecond. But best part over here is this guy. This is the heart of debouncing. It's called set timeout. What does set timeout do? Set timeout deferred calling a function for a specified duration that you provide. So here, set timeout will defer running this function for this amount of delay that you have given. Now, what is this function doing? This function is setting something called debounce value. That's exactly with the value that I have passed to this use debounce. And this set debounce value seems to be a state. So it means that if I do set debounce value over here, it is nothing but setting this particular value, which I am ultimately returning from here. Okay. So it means that even if the value comes over here, the return value from here is happening only after the delay that I am specifying. Okay. So I am actually giving you an updated value back only after a particular delay. That's all this use debounce is doing. Once this delay expires, then I am again giving you the updated value. Until the delay expires, I am not giving you the updated value, because until this delay happening, this particular function is never going to get called. If this function is never going to get called, this debounce value won't be set with a new value and you won't get a new value. As simple as that. Also, please notice in this use effect, I have a cleanup method called clear timeout. Whenever you're using something called set timeout or set interval, you have to ensure that you're clearing them as well. Okay. Now use debounce is what I got. Now how can I use it in my search box? Let's see that. So first thing first, let's import use debounce. I have imported use debounce. Call is debounce over here, pass the query, and I'm passing a new delay. Now, if it takes this query is again what? Whatever I'm putting inside the input box. So every time I put something like I put T, I put TA, I put TAP, every time I do that, it goes to use debounce as a value. And there is a delay given. Till the delay is there, it is not going to get set with any of the value that you're passing here. Not with T, not with TA, not with TAP. As it is not getting set with any new value, the value that you get from here is always the old value. Now, once this is get expired, that point in time, whatever the value you passed with that value, this debounced value will be reset and it is returned. Okay. So that value come over here. And now everywhere that we used query, instead of that, let's use debounce query. See, so that's all the code is, right? So now instead of query, I'm using a debounced query, which is a result that was created out of the query itself. But after a delay, whatever the accumulated query I got, I am returning only that. And so the output of this was also changed. Before, for each keystroke, I used to get that I'm making an API call. Now I won't get that. I'll get it only after 600 millisecond since I last typed. So if I type A, see, I'm not getting anything on the right side. Now I'll get a 600 millisecond pause. Yes, I got it. Again, E. Now 600 millisecond. See, now difference. First, it has taken where I stopped all the A's. Then again where I stopped, A. That's what you have, right? So instead of making an API call, how many A's are there? Probably 8 A's and 4 E's. Instead of making 12 calls over here, I'm making just one call. That's the huge performance boon. If I keep typing things also, see, I'll make just one API call over here. But before, without that, I used to make API call for each of the characters. That's a huge performance boon, don't you think? So this is what debounce does for us, guys. So that's another technique. The last one is about throttling. Last one means it's part one's last one. Okay. Part two, we have a lot more to cover. So in the part one, we're going to talk about throttling. First, let's see the demo. So I have a bunch of items on this UI. And again, look into the right side console.log. What I'm going to do now, I'm start scrolling this one, and this is going to show the scroll position. That's not very important. But in the right side, if you see, how often I'm making some DOM manipulation. Okay, I'm scrolling very slowly. You see, I'm scrolling very slowly, showing actually the scroll position over here 4, 5. But this one, almost 28 times is got re-rendered. Almost 28 times I made a DOM manipulation. Now see, it is going to increase. I'm very slowly I'm scrolling. It's increasing. As the scroll Y position is increasing, as the scroll Y position is increasing, I'm seeing this guy also getting increasing. Now imagine if you are doing certain painting, you're doing certain DOM manipulation, calculation, and every scroll movement, if you are doing it, minute movement of your scroll position, and if the DOM computation manipulation is something which is a bit heavier, this is not a good thing to do. That's why throttling come into picture. So what is throttling? Debouncing, where we can defer a particular function execution or the value generation for a certain period of time. We can delay it. The throttling is little bit different. In throttling, we say that within a specified span of time, I want certain things to happen at most once. Once the span is over, time span is over, again I can make it happen. That's a very big difference between debouncing and throttling. However, many gets confused. Let me just reiterate again for everyone's sake. Debouncing is delaying an execution of a function or getting a value out of something for a specified duration. So for that duration, a particular execution, particular operation is not going to repeat or take place. However, for throttling, for a particular duration, an operation is going to take place, but it is going to take place at most once. That's the difference. Now here also, we'll be using another hook called useThrottle, and the logic is pretty simple over here as well. What we do, we get that value that we want to throttle. Throttle means this particular value is going to change at most once within this particular time frame. If I pass a bigger time frame from outside, of course, it will take that. What we want to track over here, when this value was last changed. Okay, so we track it with last executed, something called, which is called date.now, when it got last changed. And here we are computing that right now, whatever the time is, which is right now, and when it was last changed, the difference between these two whether it is greater than equals to the delay that I have specified. Imagine if the last change happened on say 10 o'clock and the next change is happening at 10:15, that means there is a gap of 15 minutes in this computation. Now if I have given a delay of 20 minutes, this 15 minutes has not crossed the 20 minutes delay. So the function call is not going to happen. The new value generation is not going to happen. If this delay is say 10 minutes, but this difference is coming 15 minutes, that means I have already crossed my 10 minutes delay. So I'm allowing the recomputation of this value or the function call again. That's all, guys, about throttling. This is the core logic of throttling, nothing more than that. So it means that if a value get passed, I'm actually throttling that value for this duration. Once the duration is passed, I'm allowing it to set a new value, and the new value, the throttle value, is what returning from here. This is what the use throttle hook is. Very, very simple JavaScript logic basically. Now to make it work, pretty simple. I have to first import use throttle over here, and then instead of having this scroll y value which I'm showing over here, right? Let's do one thing. Let's use the use throttle, pass the scroll y over here, and pass this a big time, a large time, maybe 3 seconds, right? And this throttle y value instead of scroll y will be using over here. Now let us go to the UI, refresh this. Now I'm going to scroll down slowly again. See, I'll start scrolling. I'm scrolling. Okay, I got after 3 seconds. See, it is not coming on my every scroll. Look at the time. I'm scrolling. Look at the scroll, and the thing coming at the right side is much, much reduced right now. Correct? So for every scroll, it is not coming. It is coming only after every 3 seconds. It is happening only once. So my DOM manipulation has reduced a lot. So as promised, we have covered Memoization, derived state, debounce, and throttle. We also spoke about re-rendering and the problem due to that. In the next session, the part 2, we are going to cover the splitting components methodology, virtualization, going to talk about the context optimization, and also about the React compiler. However, you know that none of our session gets over without a task, right? This session, even though it's a part 1, has its task. Let's take a look into that. Okay, so these are the tasks of your part 1. Fix the broken memoization, take a look into this particular code, and the task is to make sure the child renders only once even after repeatedly clicking on increment. I have showed this already, right? So you can fix it easily. Then improve the derived state anti-pattern. I have a filtered thing and I am just doing this state changes based on something. So you know that I'm not giving you hint. And then build a small dashboard, basically a search bar with debounce, a scroll tracker with throttle. I have showed it, and then the user list with a 10k or more, filtered by search, no derived state with performance optimization, all the techniques that I have showed. Using that, just do this. Very simple. Once you do this task, I'm sure that this learning is going to go inside your brain and you are never going to forget it. All the code will be inside day 11 folder. Come to performance patterns, come to the src performance folder, and then you have memoization, debouncing, re-rendering, derived state, throttling, all this, whatever examples I've covered, everything over here. You know how to grab it. You have to go to github.com/tapaScript. Please follow this because I keep sharing a lot of awesome repositories over here. And then you can go to 15 days of React design patterns. Once this video is published, you will see day 11 and all this code that I've showed over here will be there. Also join tapaScript Discord where you can talk to other developers and we also can talk sometime and discuss things. Okay guys, stay tuned for part 2 and show your love. Please subscribe to tapaScript. Spread the words about the thing that I'm doing. That will be great help. Thank you. Take care.